The product we have is called Slaking ML. It's basically a scalable machine learning pipeline that is built on Kubernetes. There is a lot of potential for machine learning to help small and medium companies, but usually for them, there is a large overhead to build their own machine learning pipeline, since it takes quite a lot of development work and maintenance work. So therefore, our product, yeah, you can switch them. Yeah, our goal is to create this cloud machine learning platform that has all essential stages in the machine learning pipeline. And also it's scalable, easy to use, and also it is low development cost for the users.
So let's look at a demo of our product. What you're looking at is what we call Dagger. It's a visual machine learning model builder. All you have to do to build a machine learning model is to simply add some essential machine learning blocks, such as convolution, linear blocks, etc., and drag them to the editing space. Then you connect the blocks using like arrows, and this will basically give you a computational graph, and that's all you need for this machine learning model. Clicking on generate code, it gives you a code which you can paste into the new training model, like basically the model creation section. So let's say we create a new project named My Testing Training. We put on the author's name, we paste in the code, and we specify the training data that we need. Here we can also increase the number of trainers to utilize parallel training. Now you go to models list, you see that this is the model that we just created, and the training has already started at the back end. You can see the training progress at the bottom. Refresh it, and you see the training progress goes further. And we just need to wait for a while, and we are only training on like fashion MNIST for 2 epochs, and it shouldn't take long, and it seems like it's already finished. So let's click on deploy. Then we go to deploy the models. We see that a public facing IP address has been assigned. So this is the endpoint for inference. Let's see this demo application using this endpoint. This demo basically takes in the endpoint and sends a image, fashion MNIST image, to the serving model, and it gets back some prediction data and tells you what the specific item, the image of the item that you sent to is classified as. So we paste in the API endpoint we were given, and it pops up and asks you for like a fashion MNIST image. So this is just a sample demo. We just use the first one, and it tells you, okay, so this is an ankle boot. This is basically how Slaking ML works.
So the product we have is called Slaking ML. The reason why it's called Slaking is because Slaking is a Pokemon character. And in Pokemon Go, it is the character that always like just lays down. So that's what we want our customer to do. They can just lay back and we'll do all the work for them. Like the platform will do all the work for them. So here's the overview of the architecture.
So I will talk about some details about Slaking machine learning platform. And here we present a typical machine learning pipeline. So we have data collection, and typically you will have some pre-processing pipeline to process your raw data that you collected. And after you convert them to certain format that you want, you store them in a centralized data storage. And after that, what you do is you build a machine learning model, and you can typically concurrently train multiple models, and you will have to train multiple models using the same data source coming from the same centralized data storage. And after that, you will usually serialize the model by storing the parameters of the model that you just trained into another centralized storage. And after that, to use your model, to use your actual model, you will build some like model serving backend where you serve your model online, and your other microservices or even external facing, like make it external facing so that users from client will able to make requests to those model serving instances and get whatever inference results that they will need. So this is our assumed simplified machine learning workflow. And Slaking machine learning platform includes everything from data storage to model training, to model construction, to model storage, and to scalable inference endpoints construction. So we will first introduce how we are arranging our Kubernetes cluster. And in a typical Kubernetes cluster, we will have a control plane, and then we will have our computing resource pool. And within our computing resource pool, we are able to create multiple different namespaces. And the reason for creating namespaces is for controlling the type of resources that each type of services would need. And next, we will talk about some features and technical details. One essential feature of Slaking is that it's scalable and it's reliable. And we have achieved scalability and reliability through the use of Kubernetes and distributed training. In our case, we are able to use multi-container within the same pod for distributed training on Kubernetes. Each Docker image, each parallel trainer only reads part of the training data, and what they start from the same parameter, like the same trainable parameter set, but then as they train on different parts of the training data, they get different gradients, and we use all reduction methods among those gradients to make sure that all the gradients are synchronized. So that's how we achieve multi-container distributed training. And for the model serving part, we have load balancer in front of all the model serving instances. So we can freely scale however many model instances that we want at the serving. In our construction, we focused on loose coupling of different components. So the idea is that different parts of the Slaking ecosystem will be able to upgrade themselves independently. So for example, our training system is actually decoupled from the storage system. So the only thing that connects the training system to the storage system is a custom dataset loader. So in some cases, especially in larger companies, you will like to use things like message queue passing kind of mechanism for training data passing from your actual storage system, your cold storage system or warm storage system to your training instances, your machine learning trainers. So you can do that if you need to. And our persistent services such as front end, back end are also decoupled, so they can be upgraded independently, and you can test your backend APIs independent of your front end. Because everything is on Kubernetes and everything starts in a Docker image. So all you have to do is you upgrade your code, you build a new Docker image, and you push it to your Kubernetes binded Docker image registry. And that's all you have to do to upgrade any parts of a system.
Okay, and then the next feature that we're gonna cover is ease of use. So the first part of ease of use is that we have a quite simple to use web interface that includes features like a built-in editor for you to edit your Python code, and also a training progress tracker that shows you plots that is live with real-time data for you to track your training progress. Also, we also created, can switch to the next slide. Thanks. So we also created this no code machine learning model editor that this feature is mainly for like machine learning beginners so that they have a not as steep learning curve as to actually create their own model. So all you need to do is you drag those blocks into the editor and link them together. And then after that, when you click on generate code, our platform will generate this PyTorch model code for you. It's basically a model class that you can just directly put into our training system